The obvious place to start studying Earth science is to describe the Earth. The Earth is a large mass of solid, liquid, and gaseous matter that has been pulled together by gravity and that now orbits the nearest object with significantly larger mass. In Earth's case, this larger object is a star that we call the Sun. Earth revolves around the Sun, but, while it does that, it also rotates around a central axis running between the North and South poles. Since the Earth also has a lot of mass, much smaller objects and debris can fall into orbits around it. The largest and most notable of these satellites is the Moon, a solid mass about a quarter the size of the Earth that revolves around it. We've used the terms rotate and revolve a few times now, so what do they mean? Rotation is turning around an axis. Picture a top spinning on a table. It spins or rotates around a central line called an axis. The Earth has the same kind of motion as it spins in place each day. Revolution, on the other hand, involves one object moving around another. In this case, the Earth moving around the Sun. Kids playing Duck Duck Goose are revolving around the center of the circle as they play, or a person waving a towel around at a football game is revolving the towel around a central point, which in this case would be their hand. In the case of the Earth, rotation and revolution take place simultaneously, and how they do so has a great impact on how we experience life on Earth. The Earth rotates around its central axis once every 24 hours. Since the Sun is the center of the Earth's revolutions, part of the Earth is always facing the Sun, and since the Earth is also rotating, which part faces the Sun changes continuously. This change gives us night and day. At any given point in time, approximately half of the Earth is either directly or partially facing the Sun. This half of the Earth is experiencing day. The other half, the half facing away from the Sun, is experiencing night. The axis around which the Earth rotates isn't directly vertical, though. The Earth is actually tilted about 23.5 degrees. This means that while the Earth rotates, one hemisphere, either the north or the south, receives more sunlight than the other. One pole points more directly at the Sun than the other. As the Earth revolves around the Sun, which hemisphere receives the most direct sunlight changes. During a few months of the year, the northern hemisphere is angled more towards the Sun and receives longer periods of sunlight and more direct sunlight. During a few months of the year, the southern hemisphere receives longer periods of sunlight and more direct sunlight. And during some months, both hemispheres receive equal amounts of sunlight, because the Earth's tilt points perpendicular to the Sun's light, or off to the side, rather than towards it. These differences cause us to experience seasons. For those living in the northern hemisphere, days are longer and the Sun seems brighter, because our hemisphere is more directly angled towards the Sun as Earth rotates. When the southern hemisphere faces the Sun more, the northern hemisphere experiences winter. Between the winter and the summer, when neither pole points towards the Sun, we experience fall or spring. The days that the Earth points directly towards the Sun are called solstices, and the days that the Earth's tilt points perpendicular to the Sun are called equinoxes. Now that we have the basics of how the Earth moves through space, what is happening inside the Earth? The Earth is broken up into several different layers, each with its own chemical composition and physical properties: the crust, the mantle, and the core, that exchange both heat and matter between them. The crust, the layer that most people are by far the most familiar with, is actually quite thin in comparison to the other layers. The core is the dense center of the Earth and is made primarily of iron with small amounts of nickel. Essentially, as the Earth was forming and was primarily molten, the densest material sunk the furthest from the surface, pulling most of the Earth's iron to the core. The core itself actually has two parts, the inner and outer core. The inner core is solid, while the outer core is primarily fluid and circles and flows around the inner core. This movement of metals within the Earth is what creates Earth's powerful magnetic field. The mantle, which lies between the crust and the core, is primarily molten rock, less dense than the core. This layer has three main layers of its own based on their temperature and density: the mesosphere, which extends down to the core surface; the asthenosphere, which is the fluid layer on which the solid surface of the Earth floats, and the lithosphere, which is the solid rocky layer of the Earth, including the crust, and the mantle layers with which the crust interacts. The temperature gradients within the mantle create convection currents that cause fluid matter to flow towards and sink away from the surface. This ongoing process greatly influences the appearance and function of the crust above. The crust is the thin, solid layer of the Earth above the mantle and below the atmosphere. It is primarily composed of lighter materials, but it is divided into two types based on their density. The densest crust is actually thinner in terms of actual volume, but is denser and tends to sink below the other when they interact. The denser crust is called oceanic crust. The less dense but thicker crust that tends to float the highest above the mantle is called continental crust. All of the land and the ocean floor of shallow waters around the shore is continental crust. One way in which the movement of matter inside the Earth influences the surface is its ability to move large pieces of the lithosphere called tectonic plates. The lithosphere is broken into large pieces containing both oceanic and continental crust that float on the asthenosphere of the mantle. As the fluid mantle rises and falls in convection currents, these pieces move and can cause earthquakes, form volcanoes or cause them to erupt, build mountains, and even slowly move the continents on the Earth's surface. We've already mentioned Earth's magnetic field and plate tectonics, but let's take a step back and look at how these processes work in more detail. First, the fluid portion of the core, the outer core, flows in currents around the inner core. Both parts of the core are metal, though. When metals spin close to other metals, electrons start to be pulled around and organized into domains. When this happens, they produce a magnetic field. Since the Earth is so large, the magnetic field is massive. Its effects extend out into space and help protect our atmosphere and the surface of the Earth. It helps protect the surface of the Earth from solar radiation and helps maintain the composition and size of our atmosphere. Without it, Earth's surface would not support life. Also, inside the Earth, above the core, the fluids in the mantle flow and move in massive convection currents. This means that they heat up near the core, rise towards the surface, and then fall back towards Earth's center as they cool. These convection currents drive plate tectonics, causing continental drift, shaping the surface of the crust, forming volcanoes, and occasionally even earthquakes.